I'm going to start buying my subjective friends in audio some audiophile goalposts. There's been so much goalpost moving when they end up on the wrong side of not a debate, but just a point being made, and here we go. So this is over at CA, and we're talking about back to buffering and what buffering does for you. And buffering is basically us taking data, storing it somewhere at rest to read out by another protocol or application. It all goes back to jitter. It all goes back to clock domain boundaries and how we handle those clocking handoffs because you can't really sync them up. So we need some static storage somewhere where we place data that it can be read into at one rate and it can be read back out at another rate. So my point is when you're designing your audio system, you can be very holistic about it, you can be very deterministic about it, and you can design it to where we are taking advantage of our full network line rate to deliver data in these distributed systems. And my point is that Tidal and JRiver, as two examples I know about, will actually buffer or cache entire tracks. In the case of JRiver, you can actually set up to 1 gig of memory aside in your system, and JRiver will do the entire album. As an example, I took a Rachmaninoff album, put all the tracks into Audacity, and saved it back out to a single PCM file, and was able on a 10 meg network on a lowly Celeron 3150 machine with 8 gigs of RAM, start playback, and in less than 2 seconds, the entire album is transferred over because I get 332 megs a second on the 10 gig on that platform. And my point at that point, and we are back into audiophile Ethernet cables, switches, and how they really do not make a difference because you're not playing directly off the Ethernet. And Chris Connaker, he's posted several screenshots where he's going from even JRiver to an endpoint, and you don't see the same buffering behavior that I would see on like a Windows 10 endpoint instead of an NAA or something along those lines, or a DNLA endpoint. And that's fine. Those are hardware platform differences. And my point is that if you're really into this and everything matters, and you're spending gobs of money on stuff that doesn't make a difference, you might as well spend gobs of money on stuff that does make a difference. And I don't know if he's confusing what he's seeing. He's seeing a pretty smooth line where you just get some up down, some trough and crest on it. But it's still buffering. It is still data coming over, just in smaller, more incremental chunks. And my point is, why are we dealing with that? Why are we constantly popping data when we could just get full line rate on our network and go 10 gig or beyond if you really wanted to go crazy? And we can actually, get a track over in literally milliseconds. All right, so to the moving goalpost part of this, my point is that our 1200 CL says that he can't pull the cable and that stops, and that's because he has an application that is constantly buffering. And I made a point that if you're just constantly buffering, what good is it to have 1 gig Ethernet? What good is it to have 10 gig Ethernet? What is it good to have any speed above what the source material requires? And my point is that either PCM or DSD, outside of like really extreme edge examples like 32 768 PCM or DSD 1024, which I don't know anybody that has libraries and libraries where that's their standard format, because most of the stuff is not available. Most of the stuff is 1644.1. Most of the stuff is DSD like 256 at the top. So 100 megabit is fine for that. It's perfectly acceptable. You're not going to have problems. Plenty of overhead. 100 meg is good for 24192. No problems. You got plenty of bandwidth on 100 megs. And I made the point that, or you can just implement a system that's capable of taking advantage of your full wire speed, which is what you should be doing. So let's get into the moving goalpost part. So here we've got Chris coming back at me. And, we can certainly try that, and it will be 73 megabits, which is 9.125 megs a second on 100 megabit, which also means that after we take some overhead and some ACE, not getting the full, 12 and a half meg, 11.25 is more than norm. We still got 2 megs a second, which is more than enough overhead for maintenance, traffic, and everything like that. We can do DNS, we can do ping, we can do LLDP, we can do Microsoft Network Discovery Protocol, all in that 2 megs of space. Just trivial. And he's saying audio doesn't stream like a file copy. Well, in your setup, it doesn't. In my setup that I've proven, it does. So, let's look at it this way. Who has the better setup, Chris? Simple as that. Why would you put in a high performance network? So I find this disingenuous. You know better. I posted video years ago over Wi-Fi on like a generic Asus laptop where I was able to shut down the Wi-Fi adapter, and the music still played for something like 20 seconds. So this I have no problem debating back and forth. This is just, honestly, I just think if we want to look at it from a network-centric point, and we want to look at it from hardware that can realize full network bandwidth, then what I'm looking at is simply subpar, period. So here we get to my point that 73 megabits per second is 9.125 megabytes a second. And the reason that I switch up to megabytes per second is like when you do a Windows file copy, this is normally what you're going to see. This is what end users are used to seeing. So I have just basically done a conversion on the numbers and brought it into a number that most lay people are used to seeing on their Windows desktop, because let's face it, most people own Windows machines. So there we go. So I've made this point. I've also come back and saying that it sure can, and I've made my point. Even with the video that I shot years ago, where for a minute solid at the 1 minute 20 mark, I have killed the network adapters, and the audio is still playing back as witnessed by the graphic equalizer in JRiver. Another user does chime in about 32768 PCM. Totally agree that that would saturate a 100 megabit per second link. But my question is how much native content is coming into that? And I was talking about source material. And this is going to get us into our first moving of the goalpost when they find out that they are indeed incorrect. So the first thing when you're trying to make an argument is don't step in piles of shit. And this is exactly what Chris has done with this post. All right, so no, I wouldn't expect a system that's 73% if you've got a source, or if I knew that you're doing upsampling, which again, we're not talking about upsampling, we're talking about source material native. This puts the uptone audio ether regen squarely in his sights with this statement. So he wasn't meaning to, but he certainly called uptone into this because their isolated port's only 100 megabit. So first oops, and you'll see where the goalposts start really getting moved because this is pointed out by me. And Chris's second pile of shit that he has stepped in is saying that my claim about JRiver's file copy operation isn't a valid point, and this is a screenshot right from JRiver's site from I think 2013. on that release where they implemented this. And again, I did post a video that shows everything copying over with, or playing with no network connector for a minute. So it does work exactly like I said. From a caching network data perspective, if you've got a subpar setup, then it's going to take that limited hardware into account and only do what that hardware is capable of. So our first goalpost is Chris taking me way out of context, and I had to remind him that he's taking us out of context and that we he's tilting at windmills and we're talking to two different points. And I did say a PCM or DSD format. I didn't say upsampling. Now you're bringing upsampling into this. So this is Chris's first movement of the goalpost because honestly, he's just getting a good shellacking and he 100% deserves it and brought him on himself. So again, I have to bring him back to center here and screenshot again exactly what I posted about. And I was just making a point that, if we really want to, talk about this and that, we don't want to realize network speed, then why even bother with, 1 gig? Why don't we just, 100 megabits enough, right? Dial up's enough, right? If you're using the right codec and you don't care about audio quality. So, that's where we're basically accusing each other of egos or whatever getting in the way. But bottom line is Chris is incorrect, and he's just now he's taking stuff out of context. He's moving the goalpost. He's now making an argument that was never made in the first place, and he's the one that brought up 73 megabits per second. And look, I don't give two shits how you get to 73 megabits per second. I don't care if it's an actual native source. I don't care if it's upsampling. 73 megabits per second is 73 megabits per second, and you're perfectly fine on a 100 megabit connection to get that sustained, no issues. All right, so Chris has lost the 73 megabit per second argument that he's making. He knows that he can't actually push that forward any further. So we get to our next moving of the goalposts. So I am not a particular fan of using flow control for managing a network device buffer overran by the network. That should happen on the device by proper hardware selection, or it should happen upstream in the playback application. And Chris is pretend like somebody took me to the woodshed over it. I'm a dual CCNP. I have my ACEP. I do networking for a living. Flow control is a ham-fisted approach to managing an interface that's getting inundated, or CPU that is getting hammered by the data flowing into it, and it needs to issue a pause frame and back off that sending of traffic. It should be handled upstream. Another way that you can handle it without getting a lot of pause frames into the mix is we can shape the traffic going to the interface and just make sure that we basically take the gig interface, and if we have a device that's only good for half a gig, we basically just shape the traffic down to half a gig. And what will happen with the traffic shaper is anything that's over a gig, it'll just start doing some dropping of traffic for the interface, so the interface doesn't have to drop it on its own. So I do make that point, but if flow control needs to be enabled, I'll enable it. It's not a problem. Do that with iSCSI all the time. HPE, Nimble Storage, the all flash arrays, they require flow control on 10 gig connections or above. Well, they only really support 10 gig connections, I do believe, and above. But that's the point. Is if the manufacturer needs it, it's not a problem to turn it on. They just wish they were doing it another way. But nobody ever died by turning on flow control. So this is the second moving goalposts. And again, it's just you can't accuse me of being arrogant if you don't know what the hell you're talking about. This is where I show Chris has stepped in his first pile of shit. And there's a particular network switch out there, costs about 640 bucks, and its best port is only 100 meg. So welcome to it. Open mouth, insert foot. So here we finally get a concession from Chris. First off, he's saying he's countered my statements, and he hasn't countered a single statement. And if he was able to counter my statement, he wouldn't have been doing the goalpost of everything from flow control, etc. So now we are back to 73 megabits per second will work. And I'm not being disingenuous, and I'm not throwing flow control under the bus. I know it works. I'm not an idiot, but I do know how it works. I know there's better ways, and I just know some manufacturers don't do it. To each their own. And he's the one that's wanting to stick to the facts. But if I have an in-depth discussion of flow control versus other traffic congestion avoidance mechanisms, then I'm just some arrogant prig that wants to show off my networking skills. So I don't know what to say to that other than I know I know what I know, and I know how to do certain stuff, and it's beneficial to do it that way versus others. So this is just my example of audiophile goalpost moving and what it looks like, and we have another reply, and that does it for this video, and I'll talk to you soon.